Hey, welcome back, AP Calc. Today we're looking at 3.1 derivative of function. So what the derivative is a function's derivative is a function that gives a slope at any x. So there's a lot of different ways that they ask you to find the derivative, or they denote the derivative. So one way is the derivative of y is y prime. So that little tick mark there we read as prime. We can also do the same thing if we have an f of x. We can say f prime of x. They can also use this form here. It says the derivative, the top is the derivative with respect to x of y is another way they do it. And then they sometimes combine that whole thing into just the y on top. So this is also the derivative of y with respect to x. All right, so up to now we've been using this form, and this form technically always works if we want to find the derivative, but we're going to see if we can make this a little bit easier. So now is when we start talking about the formulas for each type of derivative, and we're going to start off with the one, I think we mentioned it before, that I'll write it down here, but the derivative with respect to x of x to any power is going to be, we drop down the power, and then we're going to subtract 1 from the exponent. So that's the easy way. So we've been doing this way, the hard version, the algebra intense version of our derivative up to now. And remember, that always works. So if you don't have a situation where we can just take the power, drop it down, and subtract 1 from the exponent, then you can always fall back on the algebraic version. Or if you forget at any time the formula for what you're trying to do, you can also do it using the long way. All right. So the first thing is saying is differentiate, right? So differentiate means find the derivative of f of x equals x cubed. So we noted here again, the derivative for x to the n, we just drop our exponent down. So in this case, we have an exponent of 3 that comes out in front. And then we subtract 1 from our exponent. So 3 minus 1 is 2. So we can say f prime of x equals 3x squared. So technically what this does is, if we plug in any x to our derivative function, it'll give us the slope at that same x of our original function. All right, it's important to remember as we go along in calculus, to remember that that's what the derivative means. All right, for the next one, find the derivative at a point. So what they're saying is find the derivative when x equals a. All right, so that's just something that they're giving us. So even though it says find derivative at a point, they're not giving a specific point. They're just saying for any point. And it's kind of weird, but the point to remember here is that all we're going to do is find the derivative. And then once we get the derivative, then we substitute a. All right, so let's change colors here. I'm getting tired of green. So the thing to remember, and this is the quicker you pick up on this, the easier it's going to get for you, but it's something that you need to practice, is that remember, anytime we have a root function, right, we can rewrite this as a rational, meaning a fraction, exponent. And we could do that by saying that the top is the power and the bottom is the root. All right, something from Algebra 2 and pre-calculus. So if we notice this one, there's no power on the x, so our power is going to be 1. Our root is the square root, so that's root 2. So what we did was we rewrote this as the rational exponent. Okay, step 2. We're going to apply our power rule. So we're going to subtract, or we're going to drop down the 1/2 in front of our x. And then we're going to take 1/2 and subtract the 1. So 1/2 minus 1 is negative 1/2. Oh, and then, sorry, step 3, we forgot to substitute the a, so it's going to just be 1/2 a to the negative 1/2. And that is it. So it's just applying it. This time they're saying substitute a because we're trying to find it at some point a. And it looks exactly like the derivative except for without the x. We substituted the a instead. Okay, so hopefully pretty easy. This thing here, anytime we have a root, if you can change that to a rational exponent, it's going to make your life easier. The sooner you can catch on to it, the better, because it keeps popping up. All right, the next one. This one's not so difficult conceptually, but you have to be very careful about what it's asking us to do and what it's giving us. So it's saying, graph the derivative of f. Okay, awesome. So this is f. This is the graph of f. And it's even nicely giving us the slope. So, oh, sorry, it should be the derivative of f prime. Sorry, so, oh, no, that's right. The derivative of f is f prime. Okay, so it's giving us the slope at each point. So remember, the thing to remember here, the most important thing is that the derivative gives the slope of f, right? So f prime gives the slopes of f. So because they're giving us the slopes here, all we have to do is plot the slopes at each of these points. So it's saying at the first point the slope is 4, and that's where x is 0. So at 0 we're at 1, 2, 3, 4. We're just going to plot that. At point B, which is at 1, our slope is 1. So we're going to plot that. At point C, the slope is 0. And that's at 2. So at 2, our slope is 0. So we're just plotting the slopes at each of these values of x from the f. All right, so at point D, slope is -1. So -1. At point E, which is 5, the slope is still -1. Right, -1. And then at slope f, it's back to 0, which is at 6. 1, 2, 3, 4, 5, 6. 6 is 0. And then we're just going to draw, whoops, the best we can what our graph looks like through those points. Okay, so again, the important thing to remember is they're giving us f. They want us to graph f prime, or the derivative of x. So all we're doing here is we're going to plot the slope of f, right, the original function, at each x value. So that's what it's asking us to do. And we can do this because we know that the derivative function is the slope at every value of x for our original function. All right, next one, it says graph f from f prime. So this time we're going in reverse. All right, so they're giving us the graph of the slope, and they want us to construct the graph of the original function. And they're giving us some clues here. So the first clue they're giving us is that f of 0 is 0. So this is the function, the graph of f, right? So we're going to plot 0, 0 is the first point in there. Step 2 says, or hint 2 says, f prime is shown, which you kind of already said. And then 3 says f of x is continuous for all x. All right, so let's look at our graph. So what we know is that from 1, this is 1, forward, the slope is going to be 2. So from 1 forward, the slope is going to be 2. from 1 backward, the slope is going to be negative 2. All right, so let's start at our origin. So that means that our origin, our slope is negative 2 all the way until we hit 1, right? So we're going to go all the way till we hit 1. We're going to stop there, right? Because that's where it stops being negative 2. And then, so part 3 is important here, right? So we know that f of x is continuous. So we know that from this point, our graph is going to continue from that point. So there's not going to be a gap there. And what we know here is that after 1, our slope is continuously 2. So positive 2 from that point, positive 2, positive 2, positive 2, and so on. All right, so this is the graph of an absolute value function. And we know that because our f prime is constant, meaning that the slope doesn't change, that we should have linear parts to this, right? Because the slope is unchanging, it's going to be straight lines on the left and the right. Okay, last example, and I just wanted to do this because it's something that they might ask you on the test, and it's not very hard because it's kind of like an Algebra 1 problem, even though it is asking for the tangent and the normal line. But the format that they're giving you the information in might be a little bit tricky. All right, so the first thing they're telling us is if f of 2 equals 3. So anytime you see f of 2 equals 3, remember back to algebra that this number inside the parentheses represents your x, and the value 3 is your y. So what they're giving us is a point here. So we know we're going to write this down. We have a point that they're giving us, and that's 2, 3. Okay, the second part, and this is probably not familiar to you, but if you think about it, then we should be okay with it. So f prime of 2, right? So f prime of 2 equals 5. What this is telling us is that this is the derivative, right? Derivative at 2 is equal to 5. Now, the derivative, well, that means the slope. The slope at 2 is equal to 5. So what we're given here in a weird way is a point and a slope. So in order for us to do the tangent line, well, we already know the tangent line slope at that point. It's 5. So let's just put this together. So let's do point slope form. Y minus y1 equals mx minus x1. This is point slope. And we're just going to plug it in. So the tangent line, y minus our y from our point is 3 equals slope 5, x minus our x from our point, which is 2. And then you're done. Now remember, this is very important. On your exam, if it's asking you for an equation, any equation will do. So do the easiest one, and we're doing point slope because we're given a point and a slope. So don't feel like you need to convert this into any other form just to make it nicer. In fact, if you do try to do another form and you mess up any part of it, you get credit taken off. So once you've answered the question, they're asking us find an equation. Once you've given them an equation, then stop. And the same applies for any test that we take. So as long as you give me some form of the equation, we're okay. They accept any form. Okay, part B is asking us for the normal line. So normal line. And we know that the normal line passes through the same point. So that part is going to be the same. The minus 3 and the minus 2. the only thing we need to remember is that the normal line is the perpendicular line. So it has the opposite reciprocal slope. So opposite sine reciprocal slope. So the opposite sign, it starts off with positive. The tangent is positive 5, so we're going to have a negative. And the reciprocal of 5 is 1/5. And then, again, we're done. So this is pretty easy once we understand what information it's giving us and the format that it's giving us the information in. Then it's just substituting some numbers into our point slope form. All right, that's it. Hopefully it wasn't too much today. If you have any questions, please bring them to class. We can clean them up there. We can help you out. Good job today.